this question asks us to do two things. The first thing is find the inverse of f. The second thing is tell me a bunch of stuff about its domain and range for both f and the inverse. Well, finding the inverse is pretty easy. We'll start with that. I'm going to write that equation as y equals 2x plus 13. I always pick y for f of x because that makes switching x and y very simple. I just switch them. So we get x equals 2y plus 13. And now I solve for y. I try to get y by itself. So that means x minus 13 equals 2y. And that means x minus 13 over 2 equals y. Okay, see this right here? That is the inverse that we just found for f. Now, when you get to the next part, the domain, what I want you to think for all of these things is, do you have any domain restrictions? If you have no domain restrictions, then you're not going to have any problems with writing the domain as all numbers, right? What are the things that cause domain restrictions? Where do they come from? That's the question you should ask yourself with all these problems. They come from two sources. One is you can't divide by 0, and the other is you can't square root a negative. Okay. Do we have any square roots here? Do we have any fractions? At least, do we have any fractions with x on the bottom, I should say? No. That means you're not going to have any domain restrictions. So we have negative infinity to positive infinity for both f and its inverse, since they're both linear functions. Now for the range, sometimes the easiest way to find the range is just to graph the thing. We know how to make graphs. But we have this new trick that we can do in this unit. If we know what f is, if we know what the domain of f is, I should say, that tells us what the range of its inverse is. And if we know what the domain of the inverse is, then we know what the range of f is. So for that reason, you can say negative infinity, positive infinity, all the way down, just by switching domain and range appropriately.